Hello and welcome to another free code session. My name is Jason Bach, and I'm going to do something and have a little bit of fun this morning. I've heard of this tool, more to the point I've heard of this technique, and it was one of these things that didn't really make a lot of sense to me. And it reminded me of when I first heard about mocking and not just in .NET, but in general. Why would you do that? And what are the benefits? And that was way back in like maybe 2007, 2008. And somebody on the project wanted to bring in Rhino mocks. And so we looked at it and we're like, no, the API, everything felt like, oh my God, this is so much more work than we need. But then eventually libraries like nsubstitute and MOQ made it easier to understand at least the point of what you were trying to do. So mutation testing is something I've heard of, but it never really made sense as to what you're actually trying to do. And I watched this talk yesterday, which I will put in the description. I think I watched it on my phone, but it should be in my YouTube history. I'll put it in the description so that you can take a look at it as well. And for some reason, that talk helped me understand this a little better. And so what I want to do is just play with it and see what it does and how it works. This might take all of 5 minutes or it might take a whole episode. We don't know. By we, I mean me. But I want to just investigate, see what it does, follow the instructions and play along. And we're going to do it in my Spackle library just because, why not? Give it a whirl. It's all in a branch. If it doesn't work, we just kill the branch. Okay, so we have 32. So I'm going to come over here and say new branch, 32, try striker. And if you don't get the striker reference, at least this is what I think it is, because you're trying to kill mutants. And that's what Stryker did in X-Men. So I think that's why they call it striker. But that's the intent, is that this changes your code so that what used to be like a plus is now a minus. And what should happen is your tests should fail, because that means you were testing for, like, if you were testing add, which would take 2 plus 1 and give you 3, you should have a test to say, when I pass in 2 and 1, I get 3 as my result. Well, now it would be a subtract. So you should get 2 minus 1, which is 1. And so the test should fail. And that's a good thing, because it means you're setting up tests that are actually meeting the expectations of what you're looking for. Okay. Now, the mutation testing framework can only do so much, and that it's not just, that's, I think, the thing that I was confused on is like, what is it trying to mutate here? And the thing that I, found out from the documentation is that they're targeting specific things in your implementation, like operators. In fact, if I go back over here and I take a look at the mutators, like they'll show you the arithmetic, the equality, logical, Boolean, and I'll also put the link in the description. Note to myself in the future when I'm editing this, put this in the description as well, where you can see it there, but I want to make sure that everybody can check it out later. Okay, so you should see. Actually, I need to mute this tab, because when I'm recording, Discord needs to be muted. Forget that. So there's only a handful of things it's going to look for. So it's, not going to be something. What would be interesting to see is if they have a way to do, because I think they actually change your source code. I don't think they change the binary. I'm not sure about that. I think they talk about that in the technical reference. I don't know what that is. Striker 4S. What is, oh, it's for Scala. Okay. This is for .NET. And I think they said that, they're doing this just as a code mutator. So yeah, in your code. But if they're doing that against your code, then what would be interesting to see is, maybe they already have a thing for this, is that you could add in your own mutators. So you could say, if you run into this in code, I want you to actually do this, because that's like the flip, the opposite. Okay. So yeah, and the point about this too is with code coverage is one of those things that, you know, the way I describe it is good tests should naturally have high code coverage. But high code coverage doesn't mean you have good tests. You can have a code coverage number come out that's extremely high, but your tests are not asserting for the right things, or they're just garbage. So it's just a statistic that you can't just say, oh, our number is 95%, we're good, or we need to be at 100%, which is, I think I mentioned before, there's some cases where you just can't ever hit that based on what code coverage is going to actually be able to cover in your IL. But we should at least hit 80%. Well, yeah, but are your tests actually good? And that's the intent of this, is to give you a better feel for, are your tests actually covering cases and asserting cases that they should be. Okay. So like they say here, if you have a function all enough and what they should do. And then, so that's what we're going to play with. We're going to go through this. And I think I already have the introduction getting started here. So we're going to go through the getting started and just kind of follow along with this. And I'm just going to do this in the project, do this at a project level. Okay. So create a file called .NET Tools.json if this is your first local tool. So I'm guessing we want to do this at here, I got to move my headphones over here. And don't knock over my Rubik's Cubes. There you go. Okay. So first of all, let's make the branch. Okay. And then we're going to come in here and we're going to open into a Terminal Explorer. Terminal Explorer. What is that? So, God, that would be nice if it was actually fast and being able to do that. Okay, so we want to basically do that. So now we should have, I guess it's the config file. Sure. And then we're going to install this, okay, and see what that does. Because we don't want to install it globally. We just want to do it here. You invoke the tool from this directory, tool.net, config.net tools.json. Oh, so it's in a config direct. Oh, okay. I see what it's doing. Okay, so let's go to cd spackle tests. And then they can do a .NET restore, but I've already done that. So most projects, no configuration needed. Simply run Striker and it'll find your source project to mutate. Well, let's actually do it here. So we'll do .NET Striker? Okay. Not donut, .NET Striker. Not Striper. Not Striper. Striker. Okay. And let's just, I've heard that this takes some time, which would make sense because you wanted to, go through all your stuff. Ooh, striker.net. I wonder if it's using, what is that? Yeah, spectre.console. No CS project file found. Please search. Okay, well, all right. Oh my God, that's really hard to see. So cd spackle, we'll go to tests and we'll do that again and see what that does. Yeah, that's brutally hard to see on a black background. To mutate, so identified that. It will be mutated. Analysis complete. Building test project. Okay. Test runners. Yeah, that's ouch. That's like one of my big complaints right now is it is really hard to read this text. So, but it's doing stuff. So, and they're all informational messages so far as a test run timeout. So 15, so it's 15 seconds. So if a test takes created 284 mutants. Now it's testing mutants. Okay. And it's going through and yeah, we have no coverage on this. I don't use that's something else I should go back into is coverlet and do that as, instead of trying to use the code coverage thing that I think is still only in enterprise. Maybe they moved it professional, but that should not be a Visual Studio thing. That should be a tool. So anyway, well, it's going through stuff. And it's, again, I'm okay with this taking more time and blasting the fan on my computer. Is it killing obs right now? No, not yet, but you know, I can definitely hear the fan kicking in. But again, it's kind of like benchmark.net in that I'm okay with that taking time to run, because you don't do that on every run. You would do that kind of as like a nightly build on a separate build process or something like that. I would imagine you'd want to do this the same way and not necessarily, you know, God, don't run this on every test. Like these tests itself, I believe when you run these tests, it's very quick. It's only like a second. There's not a lot of tests in this project because this isn't a big library. And I think the tests, when I've looked at the code coverage, have been pretty exhaustive from that standpoint. But we're going to see what this actually gives. So I kind of like, I mean, I don't like the color picks that they did here, but I kind of like the UI and the bar here and everything else. It's nice. Again, I wonder if they're using Spectre. They might. I have no idea. So, but we shall see. We're getting close. 99.200. Okay. Now what? Your HTML killed, survived. Ooh, half of them survived. You can open that in your browser of choice. Okay. So, okay. Did that actually preserve it? No, it did not. Okay. So let's go here and do that. Did that? No. Come on. I want you to actually copy this text. Oh my God. You cannot. There you go. Okay. So what do we got here? Killed, survived. Okay. So what survived? What does that mean? Start, compare to, end is greater than or equal to. Interesting. So if I understand this correctly, and just to be clear, I want to make sure that I don't know what this tool is doing, but yeah, all it did is add the .NET tools, which makes sense. Okay, it shouldn't just change your code here. I am interested from a technical perspective what it's actually doing. So if I go into range here, this should go off like that because we can always just tab back into there. Okay. But we do have less than and equals to. And what it's saying is it killed that and it made it just less than. And if I understand right, and I go back here and I go, what are the mutators? Probably a less than or equal to, oh, well, that's interesting. Oh, okay, so there's many, okay. Oh, that's the original. So you either do it as a greater than or as a less than, I guess. And it's saying, oh, okay. So if I come back here and turn this on, yeah, there were two cases. One that changes it to a greater than and one that changes it to a not. Well, wait a minute. That's what it was, right? Because if start, yeah, if it's a not, so it does a not to it. Okay, so yeah, it's trying to find things like that. And then there's also no coverage here. That's interesting. And do we ever actually pass in two literal objects? I think I just did some code changes because NUnit was telling me that like comparing one object literally to another, there's no reason to do that because they're going to be literally equal to each other. So interesting. Interesting. So that killed there, the contains. But let's turn this off and go to what survived. And so what's saying survived is that changing that, like if I gave you a range that's actually equal to that, yeah, let me think through this. So if this is saying that if I give a range that has both equal to, and do I have that? Range tests. Okay. So check equality, check cache code, check containment, check range with start less than end. And that should do the right thing, less than start, but I never do it where they're equal to. Well, wait, create range with end equaling start. Oh, well, I'm guessing if it's okay. So maybe what the thing is trying to tell me is why have a greater than or equal to or less than or equal to? Because if they're equal, then it doesn't matter which one is which. They're going to be 3 and 3. So what difference would that make? So let's just play with that. Let's come into here and let's just say if it's strictly less than. Okay. Now, first thing I'm going to do is just run the tests. Okay. And of course, you wouldn't be put in the right docked spot, would you? Of course not. And holy crap, are you big? Okay. So, and we want to pin that out because we just want that to come back in when we want it to. So I just want to make sure that I didn't break any tests that I already have. Okay. And we shouldn't, which is good. But now let's go back into Developer PowerShell and let's strike all the things again. Okay. Now, one thing I also want to see here is if I go to Git and I say commit or stash. Okay, good. Those are not showing up in, like if I come back here and I go to Developer PowerShell, Spackle test, striker output. That must be in a format where it's like saying don't check that in, which is good because I wouldn't want those things to keep coming in. But let's run this again and see where it does. Now I'm going to pause it here. And when it's finished, we'll see what the results are. Okay. Well, that was a little disappointing. Oh, those are the same reports. Well, no wonder. Okay. God, why doesn't this just say there? Is that different than one? No, it's not. What? 10:01:53. Fine. Since you're going to be such a pain. 10:01:53. There we go. So that's different. So we still got 8 surviving though, and those are different reports. So that's a little, like here I'm saying, oh, now it's switched it to less than equal. Well, that's, like it's not wrong. If start is less than end, then start, yeah, otherwise you flip it. This one confuses me a little bit because this is okay for it to survive. So is that saying it's okay? Like we did the mutant states. Hello? You're missing a test for it. But I'm not. What is mutation testing? If your test failed, then the mutant is killed. If your test passed, the mutant survives. The higher percentage of mutants killed, the more effective your tests are. It's that simple. Right. I get that. But I'm not really sure what you'd really want to do here. Or just saying, like flipping it, I already have a test for that. I'm almost positive. Like if I come back to range tests, all these like start less than end there with end less than start. And then it flips it to where start becomes 4. And what they're saying is, what happens if they're equal? Well, that's okay. I mean, with equaling a start, it doesn't matter. You can do that. So I'm not entirely positive that this is what I would want because it's not wrong. A test shouldn't fail in this case if you flip it. You know what I mean? Because if the mutation is to say less than or equal to, well, that's okay. Because if it's greater than or equal to, if it's strictly less, you keep it. Otherwise, you flip the 2 around. So I'm not entirely sure what this does to help. Let's go look at another one. I think I'm getting a little bit too hung up on this one. Although that got kind of curious on the extensions. Dynamic bindings. Well, exception extensions worked well. Type extensions didn't. Why didn't type extensions work well? Was no coverage. When type has element is false. And you killed it to true. Fair enough. Okay. What about dynamic? I don't want to get into that one. List of T extensions. When B does not equal 0, so it turns it into 0, and we never hit that, or we never have a test that fails because of that. But if I remember right, like if I go to, I forget which one it does. So I had a big pause there. I was reading my own documentation. And this is also something where I'm wondering if I can swap these using like a span, but that's a different story. If X does not equal Y, then we do this. Well, that's just highlighting. Oh, it killed it. Because if we equal Y, then yeah, we would have a test breaking. So that was actually good. Okay, I see what it's saying. Sorry. And then shuffle is saying, well, the length is greater than 0. Length is greater than 1. So it's not greater than 1, negate it. And then also, if its length is less than 1. And the length is equal to the self of the count on the list. So what am I missing here? I might do another episode where I've kind of gone through these and describe what these are that I've found and what do they mean. Like, okay, so if it flips this to a, not minus 1, if it flips it to less than 1, well, then what? You know, we should have a test failing apparently. So, but how can you have, you could pass in an array or a list of, 0 length because, or 1 length, and then you do length minus minus, and how would that destroy everything? Maybe that's something to look at. So I'm going to put that in here as just at least one thing to do. That was in shuffle. So I'll say shuffle. What if I pass in a list that has exactly 1 element? Because if I think about that, well, it should, okay. I'm just bouncing all over the place, aren't I? If I come back into my extensions here and I go look at, I listed T extensions, there's got to be a shuffle in here somewhere. Shuffle with null list. Previous random generated list. Okay. And then we have a mock object in here that just shuffle with null random generator. Oh, that's the random generator. Okay, that's shuffle with null list. And we're giving it a null list, but that would throw an argument null exception. We actually do not have a test in here that says what happens if you give it a list of 1. So I'm going to do that. I'm going to go through some of these mutations and dive in a little deeper off camera, and then in the next episode, I will kind of explain what I found and what these mean, and have a little bit of a better description. But I'm definitely curious. The hooks have been sunk in, so to speak, and I'm curious to learn more about this and what it's actually telling me. So next episode, hopefully, what I've learned, I will share that with you all, and we'll have more of a discussion on this. So thank you all for watching. Leave comments and questions below. See you in the next episode.